work. So how to define work and what are the special cases? Let us see one by one. That according to definition of work done, it is the dot product of force and displacement which is given by Fs cos theta actual formula. That means if this is the direction of force and this is the direction of displacement, upon making a resolution theta degrees, we got here S cos theta component and it is S perpendicular value. This particular displacement component leads for only work done because of the external force. Or in other terms, suppose this is the applied force and object is moving in this direction, angle theta degrees, and this becomes what F cos theta we can take, and obviously this becomes perpendicular component. So the F cos theta leads for a displacement of object. Therefore, we can consider that F cos theta into S. This is called as work done. So the fundamental thing is nothing but work done is equal to F bar dot S bar. We have to be taken. On the other hand, when we consider that in the coordinate system, suppose this is the first part. Second point, suppose in the three-dimension coordinate system, we imagine what this is the first position vector or position of the first object at r1 bar, and the position of the object changes to r2 bar, new position vector. In such a case, okay, we can consider that this is called r bar is equal to r2 bar minus r1 bar we have to take. Then work done is equal to here f bar dot r bar we have to be taken. Third one. Now, when you consider then sign of work, sign, okay, the sign of work will be of three types we can consider here, either positive, negative, and zero. Three possibilities are there. When do you get a positive work? If the value of theta will be within the range of 0 to 90 degrees, we have the positive work. And when do you have a negative work? If the theta value is in the range of 90 above 90 degrees and below 180 degrees, we have a negative work we have. And if theta is equal to exactly 90 degrees or net force is equal to 0 or the total displacement is equal to 0. In any one of the case, we have a 0 work done. That means three possibilities are there. So positive work, negative work and 0 work. Three cases are there. Then we will see some important applications. Now in the given problem, we have something like a rigid support like this, and here is the bomb having mass of m. This is the center of mass. If this particular system is raised by means of some horizontal force, now new position will be like this. This is the because of external force only it comes here. This is the tension T at this location and vertically downward direction mg is there. Now the total length of the system is nothing but what? Let L is the total length of the string. Now the question is nothing but the height raised is nothing but h here. Question is nothing but how much amount of work is said to be done. Here we have to be calculated. So you are see when you try to apply the force, what happen? The object displaces at certain angle theta degrees at the point of suspension. So when you try to resolve at this particular location, let h be the vertical displacement. Gravitational force acts in what direction? Downward direction. Displacement in what direction? Vertical displacement upward direction. Therefore, mg is equal to, we have what? F bar dot S bar we have to be taken. What is F bar here? Gravitation force mg. Here displacement. So vertically upward direction is h bar and horizontal displacement is nothing but x bar. Let us imagine the two displacements. Then in such a case, let us try to prepare with a more sophisticated way by using a vector diagram. This is given by gravitation force acts in what direction? Therefore, mg of minus j we can write down. Dot displacement h bar in upward direction, x bar in the horizontal x direction. Therefore, we can write down as xi plus hj. We can write down like this. That means you can write down as what? Simply minus mgh we can write down because j dot I becomes 0. Remember kids, j dot I becomes 0 and j dot j is nothing but 1. However, minus n is there, therefore I am using minus n as it is. So therefore minus mg into, we need to compute the value of what? H here. So how to find out h? When you try to prepare something like a triangle like this, actually this is L you can write down. So This portion, if it is theta, means this portion is nothing but L cos theta, you can write down. And this portion is nothing but L sin theta, I can write down. Therefore, I need this particular gap, which is h. So h is equal to actual length minus L cos theta we had to do. Therefore, you can write down as L as common 1 minus cos theta, I can write down. Therefore, mg of 1 minus cos theta I can write down into L. That means minus mgl of 1 minus cos theta is the right answer. In the examinations, 1 minus cos theta is nothing but what you write down on a 2 sine square theta by 2 to confuse us, okay? They just convert it in other form and they will give us. So by using this one can determine work done by the gravitational force we got. And what is the work done by the external force? External force is, however, opposite to the gravitation force. Therefore, minus sign is removed and you write down plus sign in the problem. So please take care of the sign convention carefully. Okay.